All right.
Amen.
And give me just a minute while I clear this. Here we go. Okay, so I'm Terry Camersell, and I'm here with Creation Fellowship Santee. We're a group of friends bound by our common agreement that the creation account, as told in Genesis, is a true depiction of how God created the earth and all life in just 6 days, about 6,000 years ago. We met for about 10 years in person at the Creation and Earth History Museum in Santee, California, but took to this on. Okay. Since June of 2020, we haven't looked back. God has blessed us with presentations from scientists, doctors, authors, pastors, cartoonists, prophecy speakers, and other talented people who love the Lord and have a message to share. You can now find links to most of our past presentations by typing in tinyurl.com/CF Santee. That's C like creation, F like fellowship, and Santee is spelled Santee. You can email us at creationfellowshipsantee@gmail.com to get on our email list so you don't miss upcoming speakers. We never spam. Joe and Stacy Gaona have been our friends and members for many years, and since Joe's homegoing last year, we always want to honor his memory by mentioning the continuing work of his ministry throughout all ages. Throughout all ages focuses on reaching people with the gospel, contending for the faith, and stirring the body to love and good works. Although they enjoy street witnessing and other evangelistic events, God has blessed them with a unique opportunity to go into public schools and speak to young people on relevant topics. You can learn more about Throughout All Ages Ministries at throughoutallages.com. And tonight, we're blessed to have Brian Lauer as our speaker. Brian has a passion to help people solidify their faith in the Bible by looking at science. The evidence overwhelmingly supports a creator, a young earth, and a worldwide flood perspective. Tragically, this information has been censored or misinterpreted by evolutionists. Community creation clubs may help people see the truth. Brian has given creation presentations from Minnesota to Florida at churches, schools, camps, and universities. He has also helped start Bible clubs and creation clubs at colleges. And you can find out more about him at solidifyyourfaith.webs.com. I hope I got that right, Brian. So Perfect. Tonight we're interested to hear his presentation about one of the possible models of the worldwide flood. It's the hydroplate theory, and we'll let him introduce that.
Well, thank you very much, Terry. I appreciate that. You hit all the high points, so we can dive right in. I will start sharing the screen, I believe. Oops, wait a minute. And I'm here basically to, I mean, I got one of my talks was censored on YouTube. So I started a Rumble channel called, let's see, where am I going here? Called Education, Not Indoctrination. Can you guys see that screen right there? Yes?
Yes.
No?
We can see, yes.
All right, okay. Yeah, and so you can see my talks on YouTube. You can see Education, Not Indoctrination on Rumble. So you can get all the information. And I'm all for a free flow of information because we need all the information to make informed decisions. And that's what I'm going to do tonight with this talk. I'm going to give you another perception on how to see things. And once you see it, you may not be able to unsee it, like these lines right here. In high school physics, Mr. Wabeke wrote this on the board, and he said, okay, anybody know what it is? And nobody did. So he said, that's a bear climbing up the other side of a tree. And just if you can if you see that, just hit like or raise a hand or something. But it's a bear climbing up the other side of the tree, and I'll color it in for you. And so when I see that, I see a bear climbing up the other side of the tree. And that's what I want to do with the earth. I want you to get another perspective of the earth. And keep in mind, throughout the history of science, experience has shown us that the simplest theory that explains the most details is probably correct. Okay. And last month I was at Living Waters Bible Camp in Wisconsin. There was a famous scientist there and speakers there. It was really a good time. And this
Brian,
is what?
Isn't that called Occam's razor?
Yeah, that's Occam's razor. And that's correct, the simplest one. Yeah, but this is their theme for the camp. It's explore, discover, wonder, and worship. And we're going to focus on wonder for about 10, 15 minutes. Have you ever wondered why the far side of the moon is different than the near side of the moon? I mean, the near side is dark, that's on the right side, and that dark stuff is lava flows. There's a lot more lava flows and a lot more moonquakes on the near side as opposed to the far side. And there's a lot more density on the near side as opposed to the far side, which is counterintuitive. It looks like it's been shot with buckshot, which is unusual. I mean, because the Earth is going to protect the near side. You know, if it's something's coming in from the left, it's going to hit the Earth. It's not going to hit the moon. Something coming in the right, it's going to hit the moon, right? And then especially when you throw in the Earth's gravitational pull. I mean, most stuff coming in from the left is going to end up on Earth, not the moon. So how come the near side is pounded and the far side is peppered? And how come the far side of the moon is colder than they expected? The nights were 30 degrees colder than they figured it should be. And how come the oldest rock found, Earth's oldest rock was found on the moon? How did that get there? And how do you get these peanut-shaped asteroids coming together? You know, how does that happen? And this is their own words. It's a major mystery how two objects, each the size of skyscrapers, could collide without blowing each other to smithereens. And it's especially puzzling in a region of the solar system where the gravitational forces would normally include collision speeds of 4,500 miles an hour. 4,500 miles an hour, and yet they're coming together gradually. You ever wonder about that? I mean, they do. And how about these rounded boulders in Comet 67P? And there's that science thing up in the left. It says Comet close-up reveals a world of surprises. Yeah, rounded boulders in space. How do you get rounded boulders? Because if they collide, it's going to be sharp edges, not rounded. And how about a frozen mammoth standing up? You ever wonder about that? How do you freeze a mammoth standing up? They found them in permafrost. This is in the Russian museum right now. And how did it get so cold so fast that could flash freeze it? Because they could still find identifiable food in its stomach. It had to be 150 degrees below zero. And then once they froze, how come they didn't thaw out? Because contrary to popular belief, woolly mammoths are not Arctic animals. They don't have wool. They don't have fur. They have hair. And this hair, they don't have any oil glands to make it waterproof. They don't have erector muscles to make it warmer. And so they aren't going to last. I mean, our nose, 1-inch nose gets cold in the winter. I mean, can you imagine if that was 6 feet long? And they eat too much, they drink too much. There's no way they can live up there. So how did they get there, and what froze them, and why didn't they thaw out? Then how do you fuse past iron? This is one of the unanswered questions that they can't answer. It's like, why is that? And then, you know, they say we're made of star stuff. The Big Bang created hydrogen, helium, and a little bit of lithium and other light atoms. But everything else, the carbon, oxygen, and almost 100 other elements that make up animals, plants, and Earth itself were made by stars. The problem is that physicists aren't quite sure how stars did it. And where'd all the limestone come from? And why are there 60,000 times more limestone on Earth than carbon dioxide in the atmosphere? Because whenever limestone is formed, it makes a particle of carbon dioxide. And there's way too little carbon dioxide for all the limestone. And Bob Dietz, he's the guy who coined the term seafloor spreading, was asked, you know, where did all the limestone come from? And he answered, beats the hell out of me. And where did the sediment come from? They asked that last month at that creation adventure. We're taking a look at the quartzite that you can see in Baraboo. And you can also see that same layer in the bottom of the Grand Canyon. And then there's sedimentary layers above it. And somebody asked, well, where did the sediment come from? And the scientist or whoever was speaking said, well, that's something to wonder about. Well, this theory is going to show you where that sediment came from. Why is the ratio 65 parts granite and 35 parts basalt in a sedimentary rock that doesn't have carbon, like limestone? How come is that? And why did it get so evenly mixed with a cementing agent like calcium carbonate and quartz? You know, if you have sand on your driveway, it's not going to turn to sandstone. You know, the sand dunes are not turning to sandstone. You have to be mixed with a cementing agent. How did that happen? And what caused the continental slope and the continental shelf? You know, why is it gradual like that? And how do you get these continental layers of sediment? Those things at the Grand Canyon, they just don't end there. They go all over the continent. And Dr. Randy Galuza, he was saying if he was in college right now, you know, they talk about uniformitarianism, present processes are the key to the past. He'd say, what present process is laying down continental layers of sediment? Not only that, they're worldwide. Thanks to Tim Clary, he's done some research. That Zuni mega sequence goes all over the world. What present process is laying down worldwide layers of sediment and fossilizing things like crazy too? And how do plateaus form? And this is a problem. It's a what mechanism would cause large volume of low-standing continent to rise rapidly a mile in the air? And the discontinuity, the Moho under the Colorado Plateau is approximately 10 kilometers greater than over most of the continental North America. So it's a double-ended mystery. For the Colorado Plateau seems to have grown downward and upward at the same time. How does that happen? You ever wondered why most of the major mountain ranges are parallel to the mid-oceanic ridges? You ever wondered how the mid-oceanic ridge got there? It's a 46,000 mile mountain range that was made. Look at the cracks. They're straight. Those are tension cracks. That's not compression cracks. Tension is when you're pulling on something and then it'll crack and then it releases the pressure. So this has tension cracks in two directions. So how do you make a mountain by stretching it in two directions? That doesn't make sense. And they had this startling discovery. The Earth's crust is missing in the Atlantic. Why is that? And why is the Pacific so much different than the other oceans? Why does it have 40,000 volcanoes? Why are all the trenches, most of the trenches in the Pacific Ocean, including the Mariana Trench, which is the deepest place on Earth? What formed that? You know, and how does 90 East Ridge form? That's a 3,000 mile straight line. That's a crack in the earth that points directly at the Himalayas. Why? Why is that? You know, how do you get marine fossils 5 miles above the sea level? What causes a mountain to form? What's the mechanism? What's the energy? What's the force? What causes the inland seas like the Gulf of Mexico and the Mediterranean? They've got a lot of salt on the bottom. Why is that? And how do you cut submarine canyons? How do you cut a canyon under the ocean? That just doesn't make sense. And some of these are longer than Grand Canyon. And in Grand Canyon, how does a little river cut a canyon 18 miles wide? And why are side canyons just as deep as Grand Canyon, but they don't have a river? Why is that? And where'd all the dirt go? There was a guy who was given tours there and he said, you know what? He'd say, I dug that. And a little kid asked him, well, where'd you put the dirt? And he said that question haunted him the rest of his life. Where did that dirt go? 800 cubic miles of Grand Canyon sediment is gone. Not only that, 2,000 cubic miles of sediment that was above the Grand Canyon is gone. Calls a great denudation. And then how come it's always so flat and pure? How did that happen? And what caused that funnel? And there's barbed canyons, which are flowing the wrong way. They're flowing into the stream and then turn around. What caused that 12-mile funnel to form? And once you see that funnel, you can't unsee it. There was a lot of water there at one time. And how do you get potholes 3,300 feet above the river on a 2,000-foot cliff that's 4 miles away from the river? And just to give you a scale of that cliff, in the bottom left corner, that dot where it says house, that's a house. And that's a 2,000-foot cliff above it. And it points to where it is, and then it points to where that pothole is. And just to the left, in that upper left, you're looking at the bottom of the canyon there. And there's there on the bottom, there's 2 more canyons like that. How do you get water flowing that fast, that far away from the river? And how do you get this layer of this rock, quartzite rock that's 5 or 10 tons high? How do you get that lifted up into the sediment? We aren't going to have time to answer this question, but you can see that on Brian Nichols' video. Also, I do a talk called Grand Canyon Answers, where that we'll be able to talk about that. And why did the river flow through the Kaibab Plateau instead of around it? Why is that? Why did the river cut hard granite instead of softer sediment in the inner gorge? It cut into the hard rock instead of eroding away the soft rock. Why is that? And how do mesas, buttes, and spires form? Well, how does a petrified tree form? How about lineaments? These are linear features on the Earth's surface, such as a fault. They're pretty much straight lines. How does that form? And how do you get a canyon in Greenland, about the size of Grand Canyon, or roughly, underneath 2 kilometers of ice? And how do you get lakes in Antarctica under 2 miles of ice? How does that happen? And it says, this textbook says South Pole is mostly covered by ice, but fossils show that dinosaurs, alligators, crocodiles, dinosaurs and palm trees once lived on the land. How does that happen? You know, and they find in the north of the Arctic Circle, they find that snakes, tortoises, alligators, badgers, shrews live in permafrost. That doesn't make sense. And what caused the ice age? And how come there isn't a glacier in parts of Alaska during the ice age where there's permafrost? Why is that? And the same thing for Siberia. How does that happen? And how do redwood trees grow in permafrost in the north of the Arctic Circle? And these things are huge. These things are, over 100 feet tall. They got 10-foot diameters, and they have a bizarre absence of oxygen 18, the heavy isotope. What's going on there? And why do comets have twice as much deuterium as the oceans? The comets have the deuterium, by the way, is hydrogen. Hydrogen is typically a proton and electron. Deuterium is you just add a neutron to that. Where do these neutrons come from to add to the hydrogen? And why is it twice as much? Okay, and why do you have stuff from the found on Earth in comets? Stuff like water, silicates, limestone, cubonite, olivine, organics, bacteria. And cubonite has to be formed in scalding hot water. Limestone has to be formed in water. How does that happen? I mean, where's the water in the solar system, especially scalding hot? I mean, Earth is the water planet. Okay, how do you get sea plankton found on the International Space Station? How did it get there? How did space plankton get into outer space, or sea plankton? Okay, and how do asteroids get moons? It's really hard to catch a moon. I mean, they've got 4 theories to explain the Earth's moon. And one of the guys says the best way to explain it is observational error. It doesn't exist because it's so hard. Uh-oh, what happened? Okay. And so, because if things are coming together, they're going to accelerate and slingshot by each other, or else they're going to collide and blow each other apart. How do you get asteroids with moons? And this one has 2 moons. How does that happen? How do you get chondrules in space? That's like the little melted rock inside a rock. How do you get them into outer space? How do you get a canyon made from water erosion on Mars? Okay, and then the comets. If they came from the Oort cloud, they should be a 50-50 mix as far as how they go around the sun. But almost all of them, 93% of them, go in the same orbit as the Earth. That's prograde. Okay, and why is that? That shouldn't be. And the midterm comets, now it's a 70-30 mix, so most of them still go in the same direction as the Earth. But the long-term ones are pretty much a 50-50 mix. Why is that? Especially if they're supposed to come from the Oort cloud. Okay. And so, this is my question. Why doesn't the moon orbit the Earth's equator? The moon is on the same orbital plane that the Earth goes around the sun. Why isn't it around the equator? And I haven't heard anybody talk about that. It's like, I wonder. Okay, so we've asked a lot of questions, a lot of wondering we're doing. Okay, but what if there was a theory out there that could answer all of this? And keep in mind, the simplest theory explaining the most details is probably correct. So with that, I submit to you, let's prepare to color in the details. Okay, what happened for me, big moments in my life, is when somebody connected the dots. My cousin Carol, she sent me a copy of this video called The Age of the Earth. And I realized that the Bible's true in every area and evolution is false, and that connected the dots. And what colored in the details, where I listened to this, I saw it, and I just can't unsee it anymore. It's like, oh, that explains everything perfectly. I listened to Walt Brown. They had Walt Brown Week on rsr.org. You can buy this at rsr.org. It's incredible. It's Walt Brown explaining his theory, talking about Grand Canyon, comets, evolution, just all of this stuff, all encompassing. And it's like, oh, that makes sense. And so what I'm going to try to do for tonight is just do a speedboat over top the surface of the theory. We aren't going to dig down too deep, but we're just going to give it a whirl. And I really have a lot of respect for Bob Enyart and Fred Williams. They've been doing Real Science Radio for I'm not sure how long. But that's my favorite website. If I want to learn something, I just go into RSR and I'll type in the subject, like dinosaur soft tissue or moon dust or whatever. And they'll have a scientist or an astronaut talking about it. And it's really funny. But on with Walt Brown. Okay. He went to West Point, Army paratrooper. West Point paratrooper, got his PhD from MIT in mechanical engineering. He did his thesis on heat transfer. So he understands heat really well. And he was a brilliant guy. He ran the Benet Military Lab, which had hundreds of scientists and dozens of PhDs. So he's got some really sharp colleagues. And actually, the Air Force wanted him to teach at the Air Force Academy, and he switched services, and it was a full colonel. So he's a sharp guy. sharp guy. He was an evolutionist. And he's driving through I think it was in the 70s. He's driving through South Dakota and he hears on the radio that somebody claimed to have found Noah's Ark on a mountain. He thought, that's crazy. But there's not much to do in South Dakota besides count down the miles to Wall Drug. So just a mental exercise, he thought, well, if they found an ark on a mountain, that would mean the whole world was flooded. That'd mean there'd be a whole bunch of plants and animals that were buried in mud. Well, that would mean that turned to fossils. And that would mean that, wait a minute, it hit him like a lightning bolt. That would mean, wait, that fossils are evidence of a flood, not evolution? And he said, where's the evidence for evolution if it's not fossils? And he started to ask his colleagues, what evidence do you have for evolution? And after 2 years of asking, he didn't have any evidence for evolution. And he became a creationist. And he came up with this theory, the hydroplate theory. And it's hundreds of pages long, or it's in the beginning. And this book is out of print. It was a $30 book. It's over $100 now because it's out of print. Okay, that's the sign of a good book when it goes up in value instead of down. And you can see it online. You go into hpt.rsr.org. You can see the flip book. It's really cool. And they're working on getting the 9th edition out. And when you have a theory, I mean, most theories go from, we know what the effect is, but we don't know what caused it. We know the effect, but it's an unknown cause. This is different. He sets up the cause with only one assumption, and then he lets the laws of physics go at it and gives us the effects, which are perfect. And I gave this book to there was a geologist at our college at St. Cloud State, and I told her, you don't have a theory that works for Grand Canyon. Do you want to see one that does? And she was curious, so she took the book and she went through it. She had it for about 6 months, and we finally got together and we talked again. And she said, if the assumption is true, the science works. She just did not believe the assumption was true. So the fewer the assumptions you have, the better. The more predictions you can make, the better. Okay, and I wish that we could save a lot of time with these theories if they couldn't publish their theory until they made an accurate prediction. That would save us a lot of time and a lot of money. But she said that if the assumption's true, what I'm about to show you is valid. Okay, and so what's the assumption? Oh, Brian Nickel does a great job too animating it. Go into YouTube, Brian Nickel. He gave me a lot of these slides. I get a lot of information. He's got the best Grand Canyon video I've ever seen, and I've seen a lot of them, and just a top notch. He knows this probably just as well, almost as well as Walt Brown. And I encourage you to check that out or buy his DVD, because they can shut down YouTube anytime they want. And so what's the assumption? Basically, just picture the Earth as a big apple. The assumption is half of the Earth, or half of the ocean water was inside the Earth, roughly a mile, or roughly 60 miles deep. It was about a mile thick. And so just think of the Earth as a big apple. The skin is 60 miles thick, made of granite. And then there's a layer of water underneath it. That's water, about a mile thick. And then underneath that is basalt. And the granite and the basalt are touching each other at thousands of places underneath the Earth. They call it, Walt Brown calls them pillars. Okay, so that's the one assumption. How it got there isn't part of the theory, but that's the one assumption. Okay, so now let's let the laws of physics go at it. You throw in the moon, because the moon's gravity tugs on the Earth twice. You get high tide twice a day. High tide and low tide, it's tugging on the Earth. It's going to tug on the crust too. And back then, the crust wasn't broken into plates like it is today. It was just the crust. So it stretched and compressed, stretched and compressed, stretched and compressed, and that added heat. It got hotter and hotter. And so the heat went into the water. And water will boil at 212 degrees at sea level. But what if you plug it up and add the pressure and just keep adding more and more heat? Eventually it becomes supercritical water. And that's what happened inside the subterranean water chambers. It wanted to boil, but it didn't have any room to expand. And so this is when liquid density and gas density are equal. And that happens at 705 degrees Fahrenheit under 3,200 PSI. It's supercritical, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So now it starts to dissolve the granite above and the basalt below, and starts to make these elements like limestone and salts and quartz. And And that's how you made the limestone, because now when it's making an element of carbon dioxide, it's getting recycled. It's not going up into the atmosphere. It's getting recycled into something else, and then it turns into limestone. It gets recycled and turns into limestone, and that's how you get all the limestone. That's where you get a lot of this sediment, too, and the cementing mixing agents are also being formed in the subterranean waters. And if you want to see more of that, Brian Nichols spoke at our Creation Club. It's we get a Rumble channel, going to Twin Cities Creation Science Association on Rumble, TCCSA, and he does a great job. Or you can go into his YouTube site too. And so what's happening here? Now a lot of those salts, a lot of those minerals, and it's getting hotter and hotter. It's getting warmer or weaker and weaker. It's dissolving the crust. So the crust is getting weaker and weaker. And eventually there's a crack in the earth. It erupts to the front, erupts to the top. Okay. And it's going to crack the earth, and it's going to go around in 2 directions at 3 miles per second. And in 2 hours, it encircles the globe. And the water, which is now under 60 miles of granite, plus all that pressure and heat, it's under 370,000 psi. So it erupts to the surface. And just to think of what water can do, keep your eye on the dumpsters. See what's going to happen at the dumpsters. Boom, that's just one water vein. Can you imagine what was happening if the whole earth did that? And the Bible tells us in the 600th year of Noah's life, in the 2nd month, the 17th day of the month, the same day were the bones of the great deep broken up and the windows of heaven were open. So that's what happened and when it happened. That's how you can get, and the water's erupting up. So that's how you can get 40 days and 40 nights of rain. Okay, and people say, well, if that happened, wouldn't it leave a mark on the earth? And the answer is yes. The mid-oceanic ridge, that's that crack that's going through the oceans there. That's the mid-oceanic ridge. That's where the fountains of the great deep broke up. And I'm not sure if you can see that circle on the right, but that's where he thinks that it ended. And so you run the movie backwards, he thinks it started up by Alaska, and then it just went all the way around. Then when it came together on itself, it stopped. And the water is just erupting out of there with tremendous force, tremendous pressure, and it just keeps going up. And so, it's raining for 40 days and 40 nights, and then it gets enough water where it covers the fountain and it can't push it up anymore. But the Bible says it keeps going up for another 110 days. So that's where the water came from. It came from inside the earth, and we'll talk about where it goes, where it went. But now keep in mind, now we got 2 60-mile cliffs. And on earth, you can only have a cliff 5 miles high before it crushes the rock below and it crumbles. So now you got 2 60-mile cliffs, and they're crumbling. That granite's crumbling into that flow. And so that's where a lot of the sedimentary rock came from, was from the granite that got eroded away from the Atlantic Ocean and the basalt underneath. That's why the ratio is 65 to 35. Okay. And that's how you get these layers here all over the continent. But what sorts them? How come they're so pure? And the mega sequence, I submit liquefaction. That's what Bob Enyart told Tim Clary. How do you get those layers? Liquefaction. You got these big waves going around the earth that pushes a lot of pressure down into the sand. And then when they go by, that pressure is released, and it just keeps going back and forth and back and forth. And that can sort things by their density. And this is a flume, a liquefaction at a flutter place. So that can do it. And so now you got all this stuff crumbling into that flow. These 2 cliffs are getting wider and wider apart. And pretty soon there's nothing pushing down on that mantle. And so the mantle bulges. That's how you get the mid-oceanic ridge. It bulges, stretching it in 2 directions. And so now it's like lifting up a train track. The train's going to start rolling. So that's what happened. The continents start sliding, and so there's even less weight on the mantle, and so that it bulges even more, and there's less, and it bulges even more. So you got North America and South America going to the west, and Africa and Europe going to the east, and they keep going until they meet resistance. And that's why their missing crust is in the mid-Atlantic. It either eroded away or it slid away. That's startling, they say. And that's why, they keep going till they meet resistance, and then they buckle up. Like if a rug going into a carpet, a wall or something's going to buckle, or a car accident, the hood buckles. That's what happened to the plates. they buckled. And that's why the mountains are mainly parallel to the ocean, the mid-oceanic ridges. And this over here, the Andes are half as big as the Rockies. And I think that's because the plate slid over the mid-oceanic ridge. And when it slid together, there's a lot of force, there's a lot of heat, there's a lot of pressure. And that's where we get our coal and our oil and our metamorphic rocks like marble and diamond. And those things still have carbon-14 in them. So they're not millions of years old. They find carbon-14 in everything that they shouldn't find it in based on that evolutionary theory. And this is, I think, in British Columbia. These are mountains that had to be soft, pliable mud when it was pushed together because there's no cracks there. They got pushed together. And you can do an experiment at home. Take your finest china and bend it. See what happens. See if it'll crack or see if it'll bend. And these are compression cracks. You know, we had talked about tension cracks, which are straight. These are compression. This is Gunnison Canyon in Colorado. They got crushed together, and as the rock's crushing, the quartz in it melts and fills up those little lines. And it's really hard to do. Okay, and you get the same type of rock, these quartz-filled cracks in crystalline rock, the same things at the inner gorge. Something crushed. I mean, a lot of force was used. And so that's how we get the mid-oceanic ridge stretched in two directions. Okay, so now how do we get plateaus? Remember that double-ended mystery? It grows up and down at the same time. What force would rise it? It's hydraulics. The mountains rose up, so you got a big mass on a small base and it sinks in to the mantle. Well, if something sinks in, something's got to rise up, and that's where the plateaus came from. What's the force? And it's hydraulics. And it just breaks out the plateau, and then the force is released, and then more builds up, so the plateau gets raised piece by piece. Okay, so it's gravity. All right, and so what's going to happen? There's going to be a lot of pressure there. The granite's going to be melting. It's going to be turning into lava. The lava is going to go up onto some cracks, and you're going to have lava on top of the soft sediment and a big wave. Water comes flowing by. It's not gonna eat into that lava. It's going to go around it. And that's how you're going to get something like Red Butte, which is downstream from the Grand Canyon, or it's in that same area. Okay, so again, similarly, if something's going up, something else has to go in. The mid-oceanic ridge is rising throughout the earth, so something has to get sucked in, and that's the Pacific Ocean. That's why you have the ring of fire, all that lava, all that instability. That's why the trenches are in the Pacific Ocean. And this is, if you get a ping pong ball and you push it together, it's going to be kind of like the Pacific Ocean. It got sucked in. And you got the the trenches, Mariana Trench. You got all those volcanoes in the Pacific Ocean. That's why, because it got sucked in. Tremendous pressure, tremendous heat. And Walt Brown said you should find some granite in the Pacific Ocean, if his theory is true. And guess what? They found Zealandia, the 8th continent. And it's about the size of India. It got sucked in there. They find fossils of land animals, and that's got sucked in. According, you would expect that if this theory was true. And okay, so now this stuff is going up and going up, and at the end of the cliffs, at the end of a nozzle, there's more pressure, so there's going to be more erosion there. And keep in mind, those things are going to be slamming up and down too, which is going to cause more erosion. That's how you get the gradual continental slope and the continental shelf. That's what happens there. That's how that came about. Okay, and how do you get the submarine canyons? Well, Walt Brown says the continents were higher back then, and the water gushed off to fill up the Pacific Ocean. So it cut those canyons when the continents were higher, and over time the continents sunk in, the oceans rose up, and the water table buried those canyons. All right. And how did this funnel happen? This 12-mile funnel? Well, what's being raised up on the Colorado Plateau are these huge lakes. Grand Lake and Hopi Lake, they're about the size of the Great Lakes. So there's a lot of water there. Plus all the water table is really high. We just had a flood. There's a lot of water in the earth at that time too. And so the plateau rises up, making a whole bunch of potential energy. And the rain keeps coming down on that side of the mountains, fills up the lakes, and eventually the lakes flow over. The lakes overflow. And so the water's gushing out, and that's how you're going to get those potholes on that cliff. The water's gushing through, you get that pothole, and then it just keeps gushing around and cuts out that canyon that's 2,000 feet deep. It keeps going down until it hits that hard Kaibab limestone, and then it spreads out. So now you have a funnel, and as it removes the sediment there, it's going to bulge. There's nothing pushing down on it, and it's going to crack. That's how you get Marble Canyon, which is different than Grand Canyon. And then it undercuts Hopi Lake, which is another potential, a lot of potential energy there. And you think Niagara Falls is coming down a lot. This thing would have been 20 times higher with 1,000 times the flow. There's just a lot of water coming out of there. And so that's going to cut out and that's going to cut it's going to erode a lot of the stuff that's above the Grand Canyon, and it's going to bulge. And that's the Kaibab Plateau bulges, and then it cracks, and then the water goes through the crack. That's why it didn't go around the Kaibab Plateau. It went through the Kaibab Plateau. So those two boxes, that's where the key to Grand Canyon is: bulging and cracking. It bulges because a whole bunch of sediment got washed away, and then it cracks, and that's where the river goes. It did that in Marble Canyon, and it did that in the Inner Gorge also. And so, and that's how you get Red Butte. I mean, Red Butte, all that stuff where the water is, that's 1,000 feet of sediment getting washed away, 2,000 cubic miles just here. And when you add the staircases and all that stuff, man, oh man, going up to Bryce and Zion, it's like 100,000 cubic miles that had to get washed away. All right, so what's different about this? They have that circle of parks or whatever they call it there, where there's really unusual things in that area. And most of the unusual stuff is at the bottom of those old lakes. That's where the Petrified Forest National Park is. How do you get petrified trees there? Well, Walt Brown says that water had a lot of silica in it. And as the solution cooled off, the silica had to go somewhere, and it went into the logs and petrified them. And you can make petrified wood by adding silica to it. And how about Monument Valley? That's where the mesas, buttes, and spires are. Okay, underneath what you're seeing here, if you dug down 1,400 feet, you'd go through sand the whole way. It's got 1,400 feet of sandstone. Okay, that means it was sand at one time. And there was a lake on top of it pushing all that water into the sand. But as the lake drained off, there's nothing pushing it down, so it comes to the surface. And it starts to flow out. And if there's something hard on top, it's going to flow out the sides. And that's how you got the mesas, buttes, and spires. They aren't millions or billions of years old. There'd be a lot more talus laying around there if it was. So basically what you're seeing here is the bottom of a lake. Okay, and how do you get the little river cut a canyon 18 miles wide? It didn't. It didn't. The canyon made the river didn't make the canyon. And why are side canyons as deep as Grand Canyon, but they don't have a river? That's because as the canyon was cutting so deep into the ground, it was cutting below the water table. So now the water in the ground is gushing into the canyon, bringing sediment with it, cutting out the side canyons, and they don't have a river. Okay, and how do you get Greenland with a canyon that's full of ice? Well, that brings us to the Ice Age. And the same thing with those subglacier lakes. It brings us to the Ice Age. Oh, and by the way, there's 90-some volcanoes beneath Antarctic ice. So if they're talking about using that to say, oh, we got global warming, we're freaking out. No, it could be the volcanoes. It's also sunspots. And if you're interested in that, I think Inconvenient Facts, everybody should read so you don't fall for that climate tyranny. And spoiler alert, carbon dioxide is plant food, not a pollutant. If we had more carbon dioxide, we'd get more food and we'd get less droughts. And a good website for that is co2science.org. And I do a talk on that on my YouTube channel also. But what caused the Ice Age? Okay, and now this is counterintuitive too, because to get an ice age, it needs to snow more than it melts. And to get that, you need warmer winters and cooler summers. How do you get, or at least warmer oceans to get more evaporation? How are you going to have warmer winters and cooler summers? Well, after the flood, the oceans were warmer, so there's more precipitation coming down on the continents. And then as the continents were higher, so it's coming down as snow instead of rain. And also there's less heat on the continents because of all the volcanoes that are going off. There's a layer of aerosols above in the atmosphere that's not letting the sun's heat to heat the surface. All right, so it snows more than it melts for about 500 years, and you get the ice age where the ice is right there. But why weren't there glaciers on parts of Alaska? Well, that's because that had a lower altitude, so it came down. And it also was closer to the warm ocean. The ocean moderated it, so it came down as rain, not snow. And that's how it was in parts of Alaska or Siberia too. Same thing. All right. So how do you get a mammoth frozen in permafrost? Any hunters out there? You shoot something, it doesn't stay up. You know, things that are alive stand up. Things that are dead tip over. This thing was standing up. How does that happen? That brings us to how to get so cold so fast during late summer. They could tell it was late summer by the food that was in the stomach. And that brings us to the cold hail. Okay, some of that stuff from the fountains of the Great Deep was going up with such tremendous speed and pressure that it escaped our atmosphere and went into outer space. And let's see, I'll admit him. Oh no, I can't. It goes into outer space, and it got super cold. And so now there's mud and water and frozen carbon dioxide, which is dry ice, gets super cold in outer space, comes crashing down on the mammoths. And that's why it froze them. And that's why it was frozen standing up. Okay, well, how come if they're temperate animals, how come they didn't thaw out? That brings it to the big roll. Okay, now keep in mind that the northern mountains and the southern mountains pretty much cancel out except for the Himalayas. The Himalayas, there's nothing in the south to cancel it out. So that big mass of the earth is trying to get to the side. And we'll show you an experiment about that. So just think of, as it rolls to the side, it's going to bring stuff on the side to the top and stuff on the top to the side. So just think of mammoths living in this temperate climate, and they're getting fat and sassy, a lot of food, a lot of water, and then the Himalayas rise up, and that's going to try to get to the equator, and it's going to bring Mammothville up to Mammoth Chill, where they never thawed out. They're in permafrost. Okay, and we're going to show you an example of this. That orange colored dot on the top is extra weight. So there's more weight on the top than there is on the bottom. And as you can see, that weight's trying to get to the equator. And so it's bringing something that was on the top to the side, and it's bringing something that's on the side to the top. That's why the mammoths got up there. They never froze. And that's how you get these snakes and tortoises and redwood trees on the top. They didn't grow there. They just ended up there. That's how you get tropical palm tree down on the Antarctic, and also alligators and crocodiles, and dinosaurs. Okay, and so that's what happened for it. Just the whole earth rolled. They didn't grow there. That's what they ended up. So how did 90 East Ridge form? Well, there's a bulge at the equator, and as it was rolling through the bulge, it cracked the earth right where the Himalayas were coming. So the crack's 3,000 miles long. So I think the earth rolled 3,000 miles. And that's how you get 90 East Ridge. That's why it's pointed directly at the Himalayas. And why does the earth, I don't know, this is just me thinking. So just take that for a grain of salt. What if the earth was spinning, maybe 90 degrees, maybe 85 degrees? What if it was more up and down? What if the moon actually did go around our equator at one time? And maybe this rolled it and shifted it. I don't know. I'm just throwing it out there. What caused the inland seas? Okay, we're going to answer a lot of questions with this one concept. What caused the inland seas? What caused the lineaments, those straight features on Earth? How do you fuse past iron? And that brings, I encourage you to check out Brian Nichols' The Origin of Radioactivity, because God said it was very good at the end of day 6. Everything was very good. Is it very good to have radioactive material that can cause birth defects? That's not very good. So what they're saying is that the radioactive those heavy elements, radioactivity, was made during the flood. And if it came from the stars, it should be spread out throughout the earth evenly, but it's not. It's mainly on the continents, and it's mainly by granite. And so we'll take a look at that. And how do you get earthquake lights linked in the rift zones? How do you get electrification phenomenon in rocks? What causes earthquake lights? Why do lights sometimes appear during an earthquake? And bizarre earthquake lights, how do you do that? Mysterious flashing earthquake lights may be explained. what's causing these sparks, this electric activity in earthquakes? Well, it's because of what granite's made of. It's quartz, feldspar, mica, and hornsplint. And by the way, granite's never been molten. If it was molten, these all have different specific gravities. They would have settled into their specific gravities, but they're all mixed up. So granite's never been molten. And quartz is 27% of the granite. And quartz is piezoelectric. Piezoelectric, that means that if you press it, if you compress it or stretch it, it's going to have an electrical charge. And could you imagine big plates of granite in tension? You know, at the top, if it's bending, there's going to be tension causing a spark, and at the bottom, it's going to be being compressed, which is going to cause a charge. And that's what was happening to the plates. As the water was gushing out, they called it fluttering. It would slam down, and then the pressure would build up enough to shoot it up again. And these things are going to come slamming down, making these Z-pinch things and melting rock. That's how you get the chondrules. They're going to go to the end, and they're going to wait there until there's enough pressure, and it's going to shoot it into outer space. That's how we get chondrules in space. And that's how we're going to get radioactive material also, because all those charges, it's causing plasma. Let's talk about how to fuse past iron. Yeah, it's really difficult, but they can do it in this thing called they have a pure electroid material. They hit something going really fast at about the speed of light, and it makes a hot dot, and it makes all these elements. And a lot of them are unstable. And then they decompose, or they decay into this valley of stability. But how does that happen? It's plasma. Like lightning is plasma. That's when the electrons are separated from their neutrons, and it's just pure energy or whatever it is. So when there's lightning, it kind of makes an expansion of the air, and then the air slams together and makes the thunder. But the rock really can't expand too much, but it does come back together with tremendous pressure, making those elements. It just slams these molecules together, and they call it cold packing. It doesn't add heat to anything. It's adiabatic. And then those things are unstable, and then they fall apart quickly, and they end up in the valley of stability. Okay. And some of the places on Earth got so hot and so much pressure that it just exploded out of there. That's how you get the inland seas. I always used to mention Lake Superior. Maybe Lake Superior is one of them, but Lake Superior, I don't believe, has the salt that's at the bottom, like it would be at the bottom of the chamber. So this is the first time I didn't say that. So that's how you get these free neutrons reacting with the water, making deuterium. And that's why you have twice as much deuterium in the comets as you do in the ocean, because the water that came up from inside the ocean mixed with the oceans, or up from inside the Earth mixed with the oceans and diluted it. And so that's why it's probably half of the ocean was inside the Earth at one time. And so how do you get all this stuff in comets that came from Earth? Well, I mean, water, silicates, limestone, all this stuff, it's on Earth. How did it get into outer space? Well, some of that stuff, and you can listen to Kevin Lee talk about this, because some of the stuff was going with such tremendous force. Not only did it leave our atmosphere, it left our gravitational pull and just kept on going. And then the big rocks would attract the water and the carbon dioxide, the dry ice, and it would come together. And you got this stuff like dirty snowballs flying around. What's described as a dirty snowball? That would be a comet. Comets, and you can listen to this. Go into rsr.org and search Kevin Lee, and you'll hear about how he talked to Dr. Brownlee, the head of the Stardust mission, and he was going to say, you know what, you're going to find stuff from Earth. And that Brownlee is more like, no, what's this from the Oort cloud? It'll be from the outer solar system. And they were just shocked when they found the stuff that came from Earth. So I encourage you to listen to that, or he spoke at our Creation Club also. Go and watch that on Rumble, TCCSA, The Origin of Comets and Asteroids. And so basically it just shot out with tremendous force, kept on going, the meteorites, the asteroids, even the trans-Neptune objects. That's why his earlier editions, he said, it's less than 10 miles of granite. And then now it's 60 because he keeps adding stuff that must have came from the Earth. And Pluto might even come, a bunch of millions of comets, who knows? And so why do the short-term comets, which come back less than 100 years, why do most of them go in the same direction as the Earth? Well, just imagine you're on a train going 100 miles an hour, and you can shoot something out at 50 miles an hour. You could shoot it straight backwards at 50 miles an hour, but you're going 100 miles an hour, so it's going to keep going the same direction as the train. That's why most of the short term are prograde, and just a 7% is retrograde. Okay, now midterm, that's 100 to 700 years. Now imagine you're going 150 miles an hour, or you're going 100 miles an hour, but you can shoot something out going 150 miles an hour. So if you shoot something straight back, it's going to keep going backwards. It's not going to come like before. And then now imagine you can shoot something out going 500 miles an hour. Now it really doesn't matter which way you shoot it, because it's going to be pretty much a 50-50 mix. It's going to keep going the way you shoot it. And that's why we have the different progrades and retrograde ratios. And how does a comet get a moon? Well, if they come together like the evolutionists think, it should just slam apart. Okay, like playing pool. But if they're going the same vector, the same velocity, coming from the same spot, they come together gradually. They may be going really fast, but compared to each other, they'll come together gradually. That's how you get peanut-shaped comets. That's how they came from the same spot, going about the same speed. That's how they could come together gradually. How do you get rounded boulders in Comet 67P? Well, the only way you get rounded boulders is if it's going through a fast flow of water, I'd say in the subterranean chambers, breaking off the sharp edges before they get shot into outer space. How do you get water canyons on Mars? Well, some of this water ended up on Mars, absorbed into absorbed into the soil and froze. And then it sat there until, it got hit by a meteor or something, which generated heat, and that melted it, caused the erosions. Okay, it's a kind of a neat theory. But if that's the case, wouldn't it leave a mark on the moon? And the answer is yes. That's why the near side looks like it's been shot with buckshot and the far side hasn't. That's why the Earth's oldest rock was found on the moon. I mean, just think of all the places that he could have been on the moon. He bends down, picks up a rock, and it came from Earth. That moon must just be covered with Earth rocks that came from Earth. Why is the far side colder than expected? It's because the near side, with that impact and that lava, that's still cooling off. And that's why the near side is warmer than the far side. Okay, and so he's made accurate predictions. Predictions are the currency of science. And that's why I wish you couldn't publish a theory until you made an accurate prediction. I'd love to see scientists just making predictions like crazy. And if somebody's right, okay, how'd you do that? But if you can't make an accurate prediction, I really don't care what you know. All right. I mean, this is some of them. Pooled water under mountains, deep channels under Bosporus and Gibraltar, salt on Mars, asteroids are flying rock piles, rocks on asteroids and comets will be rounded, water is inside large asteroids, planet X will not be found by, was it 2020? Carbon 14 in old bones. He got one of them wrong based on a mathematical error. But can you see how one theory can explain a lot of things? And again, the simplest theory and also Bob Enyart, he did a show for TCCSA about the hydroplate and its astounding predictions. So you can go in and check that. We're going to rsrs.org and /predictions. This theory explains a lot. Some of the objections are like that professor said, doesn't believe the assumption. Doesn't believe there was water under the oceans back then. My answer is, well, why not? There's water under the oceans right now. You got these black smokers, super hot water coming up from the bottom of the ocean. Where does it have to be? It has to be below that. And the Bible even gave us a clue. Hast thou entered into the springs of the sea? That's in Job 38:16. They didn't find the springs of the seas until 1977. And water should not be able to get down there, because after 5 miles of granite, it turns into like putty down there and it seals off. There's no cracks for water to get through. But Germany and Russia, they dug past 5 miles and they were shocked to find crushed granite and salt water. Isn't that interesting? And they also find water under the mountains. And speaking of the Bible, I went down to the bottom of the mountains. How would anybody know there were mountains in the ocean? And these are some of the Bible verses. To him that stretched out the earth above the waters, the earth and all its inhabitants. Okay, and I bear up the pillars of it. Okay, he gathered the waters of the sea together as a heap, and heap up in depths and storehouses. So he was storing up that water for the flood. For he founded it upon the seas and established it upon the floods. And then we talked about this one, the 600th day of Noah's life, in the second month, the 17th day of the month, the same day where all the fountains of the great deep were broken up. And who shut up the sea with doors when it brake forth as if it had issued out of the womb? Job 38:8. There's a lot of biblical references to water inside the earth. Okay, now I don't agree with everything in the hydroplate. I disagree with what they think the firmament was, but that's minor. There's a lot of good stuff here. And the water stood above the mountains. At the voice of thy thunders, they hasted away. And I'll just kind of flow through there. And you go into rsr.org/answers or /HTP. You're going to have everything you need to know about the hydroplate theory, what it is, access to the flip books, what the critics say about it, how to answer the critics. And that's what's here, the published criticisms. And that's what I was doing when I was driving all over this last month. I was listening to how they answered those critics and the hydroplate. Okay, and they're all right there. It's really good. And I gave this talk one time, and this kid said, well, if the water was so hot down there, wouldn't it make the oceans too hot to live? And I thought, that's a good question. I don't know. And so I heard one of the answers. And as gas and liquid expand, it reduces heat. So just watch this. Walt Brown says, one experiment is better than 1,000 expert opinions. And so keep in mind, 370,000 PSI expands up to 14 PSI on Earth. That's a lot of expanding. So that's going to be a lot of cooling, but just watch this.
Would I dare to take this glove away? Yeah, easy. Easy sitting there, no problem. Hot or cold? Begin with a C. It's cool, relatively cool. HC. I'm not going to put it way down at the nozzle. It turns out that which you are seeing here, gang, is not steam. That which you can't see, that's the steam. But what does that steam do? Begin with the X. Expand. And when it expands, what's it do? Begin with another C. Cool. And there's your evidence of it right there. Isn't that remarkable?
And you can do that with your hand too. Just breathe on your hand. It's warm. But if you blow on it, it's cool. It's expanding. You're putting under pressure. It expands more. And so Robin had it, it's pretty hot. Maybe it wasn't under as much pressure coming out. And there is a reason why you haven't heard about this theory, and that's the Walt Brown controversy. And so you can go into the bottom of rsr.org/HPT, go way to the bottom, Walt Brown controversy. And it really irritates me that we haven't been banging the HPT drum these last, 40 years, and every 5 or 10 years getting us an astounding prediction that's accurate. We have a lot of scientific clout right now. And so, go into, just check it out. And get all the information, come to your own conclusions. But my goal is to get Walt Brown the credit he deserves, right? And he should. He's the Isaac Newton of our day. He's just brilliant. This theory is great. You're going to have fun studying it. I encourage you to get Brian Nichols' Origin of the Grand Canyon, and also his hydroplate overview, and also Mike Snavely's a Puzzle on the Plateau does a really good job in the global flood at RSR. And here's some good sources for you. We'll just stop with this. rsr.org. It's one of my favorite. It is my favorite site. I learned so much and it's entertaining. If you want to see the flip book online, you go into hpt.rsr.org. And if you want to see everything about the hydroplate or the HPT, go into rsr.org/HPT. You can spend a month there. And if you want to see stuff visually, go into Brian Nichols' YouTube channel. And I do a little bit of it on my Solidify Your Faith. But with that, I think I've covered the high points. Thank you for sticking with me. Does anybody have any questions?
All right, well, thank you for that presentation. We do have a few questions in the chat here in Zoom. So we're going to start with one from Robin. She says, I have never heard there is sea plankton on the ISS. How do we know this?
Well, that was that article. Let me see here. Let's see. I got that one from Fred Williams. And so let's see, where was that? I'll find the source. Is there another
No,
question?
no, I asked the question before when you were wondering, that's when, then I saw
Oh, okay.
how it got up there. So that is kind of null
Okay.
right now. And the other question I was asking is, just recently on one of the creation sites, I read that now they're thinking that the Hopi and Grand Lake were not really the cause of the Grand Canyon. Have you heard that? And I mean, you have any response for it? I
Oh, no.
believe in the Grand and Hopi, but it now, I think it was AIG Answers in Genesis was saying it. I think that they've changed their position on it.
Well, that's interesting. I would ask him what did cause it. Because
Yeah.
if it was right after the flood, if it was flood runoff, it's just going to be mud. That mud's not going to stand vertical like that. It had to have time to. Oh, Joe, do you want to answer that?
Oh, well, sort of. It's
Quickly.
Okay, quickly. The I would like what you said. What do they think caused it? Because this is an opinion without evidence so far, and
Yeah, and that's just
that's
part
the
of
thing.
this theory. You know, I would suggest look at the theory at the whole. And again, the simplest theory that explains the most details is most likely correct. And yeah, I would encourage people to watch Brian Nichols' Origin of the Grand Canyon.
Yeah, I'm
And
going to check that out. Thank you.
yeah, that's the best Grand Canyon, especially with that rock. How do you get that 5 or 10 ton quartzite rock up high? How come? And this one explains, you know, in the Grand Canyon, it's got beveled, it's got slanted layers underneath flat layers. How in the world does that happen? And this theory really does explain it. And so, again, some creation, like when Dr. Galuza took over our ICR, he had people telling him, promote the ICR brand. He says,
Yes.
well, I'm going to promote creation. So there's if people don't want this to be the theory, maybe they have another theory that they're financially invested in. And what I'm saying is, let's put all the theories on the table, and the theory that explains the most data should be the one we should be pounding. And then my question to the ones who don't disagree with this theory is, what predictions have you made? What, if your theory is true, what predictions have you made based on that theory? Because we just showed like 5 or 6 of them that are astounding. You know, it just blew the doors off the evolutionists. They're just shocked. And yet, you know, Bob Enyart's there, the Bible thumping pastor on the radio, he's right. And all these PhD scientists are wrong because they disagree with God.
No, and I agree. I think the 2 legs, but I was just reading it the other day, and I'm going to find it and I'm going to send it to you.
Okay. Yeah.
Because it's got to be on their site.
Right.
Terry, was there any other questions?
Yeah, we have a couple more. We have a few more questions. So Joyce is asking, you had a slide that I think it was a article or a book called Living with the Earth, and it mentioned that the Earth is 20,000 years old. So she caught that on one of your slides, and she's wondering where that.
With 20,000, living with the Earth. Was that at the beginning when I was wondering, or was that at the end when I was answering?
Joyce, do you want to unmute yourself and answer that question when you saw it? When did you see that slide?
Yeah, I don't recall that slide.
It had living with the earth up in the corner.
Like maybe it was a quote?
No.
But what part of the presentation?
It was
Beginning,
on a
middle?
map. I don't know. It was like whenever I sent the chat.
Okay. Well, I disagree with the 20,000.
Yeah, I did too.
Yeah, a lot of people, they'll say less than 10,000, and that's fine. Some people say, most people say 6,000. But yeah, I don't know. I would.
It was like when it was talking about the oceans or something, I think.
Okay. Yeah, that must have been.
Living with the Living with the Earth was just like in the upper right corner of the photo.
Okay. Yeah. I'm not
Well, we
sure.
can find it when we're done, when we've done live stream and
Yeah.
recording. We're kind of under pressure to get that recording and live stream stopped because we have a dog issue.
Okay, so next question. Bob wants to know, he says, what is your opinion about Mars closely passing by the Earth, its gravitational pull, that was the trigger that caused the Earth's crust to break up, as opposed to your idea that it was solely due to a buildup of heat and pressure?
Well, the Mars comes by the Earth quite a bit. I don't know if that would have enough force to break up the Earth. I guess I haven't considered that. I'm just shooting from the hip right now. Mars causing the Earth, I don't know if that would have enough strength to do it, and especially to have all that water do all that destruction. I'm not sure if it could form the mountains. I'm not sure about that. I guess I'd have to look into it. I'm just, again, shooting from the hip. I can look back into it more and get back to him if he wants.
Okay. Okay, and then finally, we have a question from our friend Bill. He says, does the way we make artificial diamonds agree with how they were formed by this theory in the Earth? Also, how many years, months, or days did this theory take to happen?
Okay, I'm not sure about how artificial, how we make diamonds artificially, but my guess is it would be, heat and pressure, 1600 degrees, and I forget how many pounds of pressure to make the diamonds. I would think that's what happened in the Earth. And how many days did it take to happen? That's a good question too. Yeah, that's a real good question. I've thought of that a little bit, but I'm not sure. I'll have to look into that more, because that is a good question, because it's going to take a while to erode those cliffs so that it's far enough that they start sliding. Yeah, I don't know.
All right, so we've given you some good homework tonight,
Yeah.
Brian.
Yeah, indeed.
I think those were three things. And our resident geologist, he says that they can grow a synthetic diamond of 2 carats in 3 days or less.
Wow. Wow. That's good.
And one way to get you started on your homework about Mars is, he also says that he thinks that the Mars idea comes from I don't know how to pronounce that, Velikovsky.
Okay.
Oh, okay. But it's in the Zoom chat if you want to look at it later.
Okay, thank you.
So, well, Brian, okay. One more question. Last question, everybody. Okay. Could the reason that the same face of the moon always faces the Earth be that the density is higher on the moon on the Earth side?
Well, yeah, I would agree with that. And I would ask, how did it get denser? If it comes together by space debris coming together, it should be pretty well even. And again, the secularists really don't have a theory for the Grand Canyon, or for the moon. But I would say, yeah, that's probably why it is gravitationally locked. And my question would be, how come it's more dense on the near side as far as the far side?
Okay. All right, thank you. Okay, so let's go ahead and we're going to wrap things up for our recording and live stream. And then those people in Zoom can hang back with us and ask a few more questions directly to you. But before we go, Brian, can you let people know again how they can find you and your ministry?
I've got a YouTube channel called Solidify Your Faith, and that's creation. And if you're interested in the tyranny that's been rolling around these last couple of years, I've got a Rumble channel called Education Not Indoctrination, it's just all one word. And my email is solidifyyourfaith@hotmail.com.
Okay, and we're looking forward to having you back in November for that other side of the conversation, right? So what was the name of that talk going to be again?
It's going to be, oh, go ahead. I'm sorry.
It's Prepared for the Battle.
Prepare for the battle. All right, so be looking forward to that, and look for information on our Facebook page, Creation Fellowship Santee, because we'll create an event for that also. That'll be November 10th. So next week we have Kay Rubicek. She is an author. She's the author of a book called Who Are China's Walking Dead, and she'll be speaking for us. Be sure to find our partner ministry, Throughout All Ages Ministries, at throughoutallages.com. And of course, you can find most of our past presentations by looking at the URL tinyurl.com/CF Santee, or you can email us at creationfellowshipsantee@gmail.com. So with that, we're going to go ahead and sign off for tonight.